Me again, Ms. Popelka, working part 2 of the Algebra Retake Study Guide. So for number 9, we are solving this inequality for R, and thankfully for us, it's pretty much just like solving an equation. So that means that we already kind of know what to do. So this 2 outside of this parentheses tells us we're going to distribute the 2 to the 8R, which gives us 16R, and the 2 to the negative 4, which gives us negative 8. And we're going to set it greater to, this 2 on the right side is just kind of hanging out by itself for a second. But we do need to distribute this negative 8 to these 2 items inside of the parentheses. So that's going to give us negative 16R, and then 8 times positive 2.5 is going to give us a negative 20. Sorry about that. Okay, I've also got a couple of like terms over here that I combine. So on the right side of the inequality sign now, I've still got that negative 16R, but 2 minus 20 is negative 18. So now I've got just a plain old equation, well not equation, inequality, sorry, with a variable on each side. I'm going to get rid of this negative 16R with a positive 16R. That is going to leave us with 32R minus 8 on the left-hand side is greater than negative 18. I'm going to cancel out this negative 8 by adding positive 8 to both sides. That'll leave us with negative 32R is greater than negative 10. And this answer does come out to be kind of a little bit of a silly one. If we do negative 10 divided by 32, we have some different options for how we can leave our final answer. Okay, so we can either say that 30 is greater than negative 10 over 32. You could divide it out, so that would be a R is greater than negative 0.3125. Either one of those is okay, but R is greater than either one of those options. Number 10 is another one of those kind of silly polynomial questions. It says that the profit for a company is modeled with this expression, and the expenses are modeled by this expression. What is the sum of the expenses and the profit? Well, of course, we all know that sum means add. So all we're doing is combining the like terms. So I've got a 7x squared and a 9x squared that I'm going to combine for a 16x squared. Whoops. Then I've got a 6x that doesn't have anything to combine with because we don't have any other x's. We'll just leave that as a negative 6x. But then I have here a negative 5, a negative 12, and a 4, which all need to be combined, which is going to leave us with a negative 13. So your final answer is 16x squared minus 6x minus 13, because since it says sum, we're just going to add those together, which just means we're combining like terms. For number 11, we've got a little real-life situation here. We need to figure out which one of these statements is true. So Florence owed her mother $30, but she gets a job that pays $225 a week. And her friend has also gotten a job, and her savings are represented by this graph. So we have to figure out which one is actually the true statement. So let's see. A, Florence starts out with more money than Raquel. Well, no, because actually, even though this isn't how they really intended it, according to the answer key, sorry, I paused that for a second because I had to look at something. So notice it says that Florence owes her mother $30 and gets a job that pays $225 a week. Then after she pays her mother back, she's going to deposit her paychecks into a savings account. So that means, or you can make the inference that the first time she makes $225 and takes away that $30 that she owes her mother, she's going to deposit $195 into that savings account, which means she's actually going to start off with $195 in her savings account. Raquel, according to the graph, at 0 weeks starts off with $100 in her savings account. So actually, A could be correct based on the way that you interpret that. Florence starts out with more money than Raquel in her savings account. But also, there's another one that is true because Florence makes more money per week than Raquel. Well, how much does Florence make per week? Well, she makes $225, because it tells you that. Let's see how much Raquel makes a week. So if you look at the difference from 0 to 1 week, so after 1 week, it went from 100 to 250. So she makes $150 per week. So in fact, there are two true statements, despite what my answer key says. That's not good. Okay, that Florence starts out with more money, and she makes more money per week than Raquel does as well. So actually, A and B are both correct statements. For number 12, it's asking which table represents the relationship between X and Y. On your paper, I know it goes up and down. I just put mine across so that it would all kind of show up on one paper. So first of all, this equation right here, since it's a negative 3x, that tells me that the rate of change is negative 3. So let's just start off there and see which one of them has a rate of change of negative 3. So from negative 12 up to 9, that is a positive increase of 21. My change in x from 6 down to negative 1 is a decrease of 7. Remember, rate of change is your change in your y values over your change in your x values. So 21 over negative 7 gives me a negative 3. Oh, I think I found our rate of change. Let's just double check really quickly and look at it at the other two to make sure. So from 20 to 35, we're going up by 15. From negative 4 down to negative 9, we are going down 5. So this would be 15 over negative 5. Ooh, that one is also a negative 3. So maybe we've got a problem. This is a good way to show you guys that don't just go with the first one just because. We better double check and make sure that the third one doesn't have the same rate of change as well. So from 5 to negative 4, that is going down. Oh, I'm sorry, that's going up by 1. So that's a positive 1. From 8 to 7, that is going down 1. So positive 1 over a negative 1 is a negative 1. This one definitely does not have the rate of change we're looking for. So let's look at our two options that we have left. Now we might need to take the numbers and plug one in for x and see what our answer is for y. But in this case, we actually don't have to, because I recall that my y-intercept is whatever my y value is when my x is 0. Here, I've got a 0, 6 in my table, so that tells me that this first table, your top one on your paper, is going to be the correct one. So now we've got two different functions in number 13, and we need to figure out which two statements are true about those two functions. So first of all, let's just see. A says the x-intercept of figure 1 is less than the x-intercept of figure 2. Well, let's see if that one's true. So the x-intercept of figure 1 is right there, where it crosses the x-axis. So the x-intercept of figure 1 is a negative 2. The x-intercept for figure 2, remember the x-intercept, the same way that your y-intercept is whatever y is when x is 0, the x-intercept is whatever x is when y is 0. So the x-intercept for figure 2 is a 3. So this is in fact correct. The x-intercept of figure 1 is less than the x-intercept of figure 2, because obviously negative 2 is smaller than 3. So we got to figure out which second one is also true. And let's see. So B says the y-intercept of figure 1 is greater than the y-intercept of figure 2. So the y-intercept of figure 1 is a 4. The y-intercept of figure 2 is 12. So no, that's not right, because figure 2's y-intercept is actually bigger. So I'm going to mark out B. For letter C, it says the rate of change of figure 2 is greater than the rate of change for figure 1. So let's see, figure 1, I'm going to put my, so I'm right here at the 2, and then it crosses right there at the 6. So my rate of change, it's going to go, so a 6 and then over 2. So that's going to be a 6 over 2, which simplifies to a 3. This one is going up by 4, then going down by 1. So its rate of change is a negative 4 over 1, which simplifies to a -4. Don't let it fool you and think that C is not correct. Remember when we're talking about rate of change, when we say greater, I know you're probably thinking that figure 1's rate of change is actually greater because 3 is greater than -4. But when we're talking about rate of change, a better way to think about it is by saying which one is more dramatic, let's say. Changing by going down by 4 is a more dramatic change than going up by 3. So therefore, A and C are correct because the rate of change for figure 2 is larger than the rate of change for figure 1. Number 14 asks us to evaluate this function when f is when f of x, instead of f of x, it's f of -7. So that means we need to take the x in the equation and put in a -7. So all I'm doing is replacing the x's in that function with a -7. Of course, we know in order of operations, we've got to do the exponent first. So -7 times -7 is a positive 49. Then I'm going to take 3 times 49. That's going to give me 147 plus, 12 times x. So that's going to be 12 times a -7, which is going to give me a -84 minus 2. If I do 147 minus 84 minus 2, I'm going to end up with 61 for my final answer. For number 15, it says solve the system for y. So we've got 2x plus 3y equals 20. I'm going to kind of write them over here. Actually, I'm not going to rewrite them because they're actually set up perfectly right now the way they are for elimination, because positive 3 and -3y are right on top of each other, which makes for a 0 pair. So remember, I'm going to add everything together on the left side of my equal sign. So it's going to give me a 9x. And then on the right side of my equal sign, 20 plus 8 equals 28. I'm going to divide both sides by 9. So my x is equal to, I'm just going to round to about 3.1. Now, please don't stop and think that you're finished like some of you guys did on the last practice. Remember that it's asking us to solve for y, not asking us to solve for x. So now that we know what y is equal to, now that we know what x is equal to, we've got to use that value to go back and figure out what y is equal to. So I'm going to take this first equation, and now I'm going to rewrite it over here. Instead of 2 times x, I'm going to do 2 times 3.1 plus 3y is equal to 20. I'm going to do 2 times 3.1. That got me 6.2 plus 3y equals 20. I'm going to subtract 6.2 from both sides. That's going to leave me with a 3y. And then 20 minus 6.2 is 13.8. I'm going to divide both sides by 3. Y is equal to 4.6. So now I've solved for y. My final answer is 4.6. For number 16, we've got two ladies that babysit. Mary has the equation y equals 20 plus 5x to represent her total amount of money because she charges $5 per hour. So that's where that x comes from. X represents per hour. Then it says that Sandra charges $10 per hour. So her equation is y equals 10 plus 10x. But again, the x stands for the number of hours. So it's asking us, and then the y for both of them stands for their total amount of money that they make. So the question says, after how many hours of working will they have made the same amount of money? Well, since they're both y equals, I'm just going to set these equal to each other. And I'm just going to rewrite it into one big equation to see at what point does 20 plus 5x become equal to 10 plus 10x. So I'm going to subtract both sides. 20 is equal to 10 plus 10x. Subtract 10 for both sides. 10 is equal to 10x. Then we're going to divide both sides by 10. So that means that they will actually be the same. Oh my gosh. Oops, boo-boo. 10 minus 5x certainly isn't 10x. Duh, Miss Papelka. It's going to be 5x, which is going to change things a little bit. Sorry, let me just back up for 1 second to make sure nobody's confused. Sorry about that, guys. All right. So I subtracted 5x from both sides. That gave me 20 over here. Gives me 10 over here. 10x minus 5x is 5x. If I subtract 10 from both sides, that gives me 10 is equal to 5x. Then if I divide both sides by 5, that is going to leave me with 2 is equal to x. I have no idea what's going on with me today. So 2. Last but not least, for the multiple choice, we've got a system to solve. It's awfully tempting for you to look at these and think that they're set up directly for elimination, but they're not. Because notice that this 3x is on the right side of the equation, of the equal sign. This one is on the left side, so they are out of alignment. So we need to fix that. So I'm going to take this one, I believe, and this is the one I'm going to change. So I've got 2y is equal to negative 3x plus 5. So in order to change it so that it's lined up with the bottom one, I need to get this 3x over to the other side. So I need to add 3x's to both sides. So that's going to give me, I'm going to end up with 2y plus 3x is equal to 5. So now instead of that equation, I'm going to write my new one underneath the one on the top. Now we still got a positive 3x and a positive 3x. So I've got to do something to set, they're still not a zero pair. They're not going to cancel each other out. And I've got a positive 2y and a positive 2y. So they're not going to cancel out either. So I need to choose one of these equations. Doesn't matter which one. I'm just going to choose the top just because. And multiply it by negative 1. Multiply everything straight across by negative 1. So I've got negative 2y minus 3x is equal to negative 10. Then here we've got 2y plus 3x is equal to 5. Now there's something a little fishy going on here that might ring a bell from back when we solved multi-step equations, but it's been a minute since we've seen this. Notice right now, negative 2y and positive 2y are going to cancel out, and negative 3x and positive 3x are also going to cancel out. Uh-oh. So I've got a 0 over here on my left-hand side, but negative 10 plus 5 is a negative 5. Negative 5 can't be equal to 0. So this is actually an example of a system of equations. This might be ringing a bell for you, where there is no solution, because 0 can't possibly be equal to negative 5.